applying this idea, now we could treat this as a formula. Anytime we have an equation of this form, this is a formula for a solution function. And we could memorize this as a formula, but for most people, it's better to simply understand why it works and apply it, and that's the way I'm going to approach it here. Okay, we got y prime plus y square root of t times y prime plus y equals 0. Now that's not in this form, so let's go ahead and be sure we put it into this form first. All we have to do is divide by the square root of t and make a note that now t can't equal 0. So we have y prime plus 1 over the square root of t times y equals 0. T not equal to 0. Now this could be written as t to the negative 1/2 or 1 over the square root of t. Now we're going to let y of t equal e to something. And that something has to have a derivative that's equal to 1 over the square root of t. So what's that? And it has to be negative so that our y prime term will have a negative of what our y term has. Okay, so what's our question mark? Well, the derivative of our question mark must be negative 1 over the square root of t. Now we can integrate 1 over the square root of t and determine this, but I'm simply going to assume that everybody can find the fact that the integral of 1 over the square root of t is, well, if we take the derivative of the square root of t, we get 1 over 2 square root of t. So it's going to be 2 times the square root of t. Okay, so that y of t is going to equal e to the 2 square root of t, negative 2 square root of t. Y prime of t then equals negative 1 over the square root of t times e to the negative 2 square root of t. And we can verify that this function satisfies the condition that we have here. Let's consider ty prime equals y. Now this can be put in the form t y prime minus y equals 0, which is the form y prime minus 1 over t times y equals 0. What do we put in the derivative, in the exponent of our exponential function here? Well, y of t is going to equal e to the integral of, well, negative integral of negative 1 over t dt. The integral 1 over t is just a natural log of t, so that's e to the natural log of t, which is just t. Does that work? Does t times t prime minus t equals 0? Well, you can easily check that t prime is 1, that's t times 1 minus t equals 0, that's t minus t equals 0, and that's true.